Hi, Assalamualaikum. My name is Muhammad Firdaus bin Jamaluddin and my metric number is B081910181. So basically, our team is supposed to design a gated SR latch door for the Vlsi design and fabrication subject. As we can see, this is our group members, which is including me as the project manager, and then we got the Muhammad Amirul Alif bin Abdullah as a component design engineer, and Muhammad Azimanzi bin Azhar as a master design engineer, and finally Muhammad Alif Hafiz bin Muhammad as a project analyzer. And now we will moving on to our introduction. Basically, it will be explained briefly about the project, the objective, and also the equipment that will be used in this project. As we can see, we have three input over here, which is S, R, and E, which is S stand for set, R stand for reset, and also E stand for the enable. And then we had two output, which is Q and Q bar, and also the function of E is to become a latch. As we can see, when the E equal to 0, the output of both AND gate are constrained to be equal to 0, independent of the state that S or R may be in. Because of this, the circuit acts as though both S and R were 0, which caused it to latch the Q and not Q output in their most recent state. The latch will not respond to S and R input until the enable input is first engaged. And then we move on to our objective, which is our objective is to familiar with the gated SR latch node, and second is to simulate the gated into schematic and layout form, and lastly to work effectively in our own group under the instruction of the project manager. And then moving on to the equipment, as we can see, we are using our personal computer and also the layout editor software. And that is the brief explanation from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif bin Muhammad. My meter number is B0819100066. Okay, today my role is going to be the project analyzer. So I will present about the project planning. In this project planning, we will discuss about the Gantt chart table and also the simple timeline. So we're going to next. So the milestone, or we call it as the timeline. In the week 1, we do some research and also planning about our project. Okay, in the week 2, we're going to get the output from the waveform, from the schematic diagram and also from the layout diagram, and we do the troubleshoot between them. And then in week 3, we do the implementation in the report, which we include all the observation from the waveform into the report. And in week 3 also, we got the assessment from our lecturer, from Dr. Shafiq bin Misman. Okay, in the week 4, we do the report submission. Okay, next we're going to the Gantt chart table. So here I include the few task name. So in the week 1, we do the research and planning, and week 2, first day and second day, we do the schematic waveform, and fourth day and fifth day, we do the layout waveform. Okay, and in the week 2, we do the troubleshoot for schematic waveform and also the layout waveform. Okay, in the week 3, we have do the implementation report, which mean we do we take the output from the layout and also the schematic and put it into the report, and also we find the propagation delay from here. And then also in the fourth day, we have the psychomotor assessment with our lecture, and the fifth day we complete our video. And the first day in the week 4, we have to submit the report and also the video. So then we're going to the project flow. In project flow, I will explain briefly about the IC design flow. So this is the IC design flow chart. So it's starting with the design specification, means we find out what's IC we want to design, and then we're going to the schematic. We do some research and we do the schematic diagram in the schematic layout software, and then we do the simulation to find the waveform and also the output, which is whether it is correct or not. And then after that, we going to the schematic again, and we restructure the schematic layout to do the layout diagram. So in the layout diagram, after we do the layout, we need to do some design rule check. If there is a problem or not. If there is problem, we're going back into the layout and we recreate the problem. And if they don't have any problem, we're going to the extraction and do the LVS layout versus schematic check. So in the LVS, if there any problem again, we're going back to the layout and recreate it again. And if there is no problem, we're going to the post layout simulation. So in this post layout simulation, we will get the output for the propagation delay, which we need to find both schematic and also the layout diagram. So from the schematic and layout diagram, we need to compare between the propagation delay, and then we're going back to the schematic, and it's the end of the IC design flowchart. Okay, that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Azim Hamzi bin Azhar. Okay, so I'm from group 1 and my topic for this assignment is gated SR latch with no gate. Okay, so I will explain about the schematic design of full gated SR latch with no gate, and basically this is the construction to do based on the topic, which consists of 2 AND gate and 2 NOR gate, and this is the connection that I got from my group research. So this is vPulse that give the waveform and then this is the VDD VSS for the power source. We connect directly to this gate. Okay. And this is the transient simulation which I set to the period is 400 nanosecond. Okay. The input port is R, which is reset, E enable, and S set, and the output port is Q and Q bar. Okay, without wasting any time, I will go to the LT spice and start to begin to view the waveform. Okay, firstly I need to change the F to P. Okay, and run. Okay, so this is the waveform I got, and we can do this comparison to this truth table to double check whether the waveform is correct or not. So far it is correct. Okay. This is the waveform that generate from the schematic, and I already calculate the propagation delay, which is here. This is TP high to low, as we can see here, input high, output low. So the delay is 38.7446 picosecond, and for TP low high, when the output is low and the input is low and the output is high, the delay is 74.1374 picosecond. So the propagation delay, we add those numbers and divide it by 2, and then the delay for the schematic layout schematic before layout is 56.441 picosecond. Okay. To find the propagation delay, we need to find the exactly 600 millivolt, because we need to find half of the power source, which is 1.2 volt. So 1.2 divided by 2 is 0.6 volt or 600 millivolt. So this point is roughly correct to the 600 volt, and then the result is here. that's all from me. Thank you, sir.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Alif bin Abdullah. My role is Mass Designer Engineer. Firstly, this is the design for the layout that we create. Okay, we use two AND gate and two NOR gate, and the input is reset, enable, and set, and the output is Q and Q bar. And then we create the layout design. Okay, this is the layout design that we create. We connect the connection, use metal 2 and the via 1. Okay, and then we use the extraction and the LVS. The LVS is no error, and then we check the DRC. Okay, design rule checker, one cell, no name. Okay, and then we go to the extraction and open the netlist. Okay, this is the netlist that we create. We just divide by 1000 and turn Eto to femto, and then we just add the line for V1 until V5 and the transition 1P 400N. We simulate the waveform. Okay, this is the waveform for the gated SR knowledge. Okay, we can see if the enable is 0 and then the SOR is 1 0, the Q and Q bar will be latched. It will at the stable state, and then if E is 1 and S is 0 and R is 0, the Q and Q bar will be latched and will be whole. The value will be same as the before. And then if the E is 1, S is 0, R is 1, Q is 0 and the Q bar is 1. And if E is 1, S is 1, R is 0, Q will be 1 and Q bar will be 0. And lastly, if E is 1, S is 1, R is 1, the Q and Q bar will be invalid. Okay. Firstly, for the propagation delay, at the point 125 nanosecond, we find the TPHL. And for the TPLH, we find at the point 150 nanosecond. Okay, the propagation delay, we have done the calculation. Yes. This is the value for the TPHL, 39.21943 picosecond, and the TPLH is 71.452168 picosecond. Okay. The formula for the propagation delay is TPLH plus TPHL divided by 2. And then the answer is 55.3358 picosecond. Okay, that's all from us. Thank you, sir.